Okay, let's repeat. Let's continue. Sorry, repeat. We were talking about electromagnetic radiation for the solar ray. All right, the components of the spectrum. We talked about from the understanding of the physical properties from the radiation and the relationship between the frequency of the radiation and the energy is directly proportional. But for the wavelengths of the radiation and the energy relationship is inversely proportional. And we already explained in part 8, now part 9, we continue on radiation spectrum and energy. Alright, we're still using the same diagram, and we continue. We finished gamma ray. Alright, gamma ray, it's a very, very strong and harmful ray, and short wavelengths, alright, high frequency, high energy, high penetration power, alright. All these we talked about in the past. Now we're getting X-ray. What is X-ray? X-ray, everybody knows. You took X-ray examination to check if you have a fracture on your bones. If you're athletes, right? You fell and then you hurt and you may have crack on your bone. And then why the X-ray is able to check the bone, which is internal, right, from your body, because the wavelengths. The wavelengths of X-ray is very short. It's short enough to penetrate your skin and your cell, pass by, also at the same time get those cell and skin cell, muscle exposed to X-ray, and it was higher and higher because the time longer and longer, the higher and higher exposure and dose, and the kill those cell I already mentioned last time. That's going to cause you cancer in the blood or other kinds. The blood cancer is called leukemia, right? So, but it's the wavelengths, X-ray wavelengths of X-ray is not short enough to pass or penetrate into the bone, which is based on phosphorus and calcium. Those atoms are metal, right? And then they are tightly packed. And if you're young, you have very high bone density, which means you have very high calcium contents not excreted from your body yet until you pass 50 or 60 years old, especially for ladies, right? So you lose a lot of calcium. But if you're not, your healthy bone is able to, the calcium, the atom, the metal atom, is able to stop the X-ray penetrate them. So what happens if you have a shining flashlight to a tree? Of course, the flashlight is a visible light, has a longer wavelengths. It cannot penetrate the tree trunk. So the light will be stopped by the tree trunk, right? If during the day you will see a shadow of the tree trunk behind the tree trunk, that's a shadow, right? Then the same situation happens at X-ray examination. The bone, just like the tree trunk, stopped X-ray, and in the back is X-ray plate, the film, right? And the film was not getting exposed by X-ray radiation, so the bone will leave a shadow, just like a tree trunk shadow, onto the film, which shows supposed to be black, but only if you print out the negative. The film is negative, right? And otherwise, the negative film, which we are using all the time in the hospital, doctor look the film, not look the prints, is going to be white because it's opposite, right? It's called negative. Negative means opposite. So dark shadow on a negative film is going to be white or transparent. But other tissues, the X-ray radiation is able to penetrate, will leave a black shadow on the negative film, which when you print out, it will reverse, will be white. So that's the situation. You see the black bone in white color, and if you see crack, there will be a fine thin line, curved and the zigzag. That's where the fracture occurred to the location where you got hurt. So that's how X-ray is able to examine your body, right? right? So of course the cancer is it's a little bit nodule, and then they got concentrated with a mass and overgrown, out of control. That's a cancer or tumor, and X-ray is able to spot it because X-ray is not having shorter enough wavelengths to penetrate that or leave a shadow on the film. So you see, oh, there is something abnormal because everything else is supposed to be black, like a normal tissue, but that nodule for the tumor or cancer will show a white spot, right? That's what happened to my mother. She had a stage 4 lung cancer, and then she passed away. So that's X-ray. Now X-ray, and then what's the application for X-ray? We of course we know CT cut scan, right? CT, right? Cut scan. All right. So this is X-ray, and then next to X-ray is what? We moving from left, which is high frequency, shorter wavelengths, right? High energy, to the right, getting lower frequency, longer wavelengths. So the next will be UV. Everybody knows the shorthand UV stands for ultraviolet. Ultraviolet is also harmful. Now, so it is also strong enough, has a higher, pretty high frequency and shorter wavelengths, but it's not shorter as X-ray. So the UV radiation is not able to penetrate too deep into a body. So now when you think about it, in your life routine, if the sun is shining in the summer, what are you going to use to protect your vision? You wear sunglasses, right? And the regular cheap sunglasses doesn't say UV protected. UV radiation protected. What is UV radiation protected? It was the sunglass, the shade, the glass was coated with a thin film of some kind of material, is able to block the UV radiation, penetrate that film, thin film, and then get to your eye. Why? We want to protect the eye from UV radiation. Even the UV radiation is not as harmful as X-ray, but it's harmful enough to hurt the soft tissue. Right? In the human body or any mammal's body, the eye is the tenderest organ of the human body or mammal. Right? So the UV ray is able to penetrate your very thin membrane of your eyeball and it can hurt your retina, and then that's long-term effect and get your vision distorted. So that's why we have to use UV coated sunglasses in the summer to protect your eye being hurt by the solar ray from the sun, right? And UV, all right, also is strong enough to penetrate the skin. So that's why people go sunbathing. They put some film, right, sunbathing lotion to protect your skin. And if you don't know, I will have to tell you, if you got skin cancer, that's terrible. Skin cancer, I think it is the second worst cancer, under pancreatic cancer. Pancreatic cancer is the worst. And skin cancer also kills. Then you got liver cancer, the third. I think, I'm not medical knowledgeable, but I think so. And then the liver, and then probably colon cancer is the best cancer you can have. It's not going to kill you instantly if you have surgery discovered earlier, right? But skin cancer definitely will kill if they find. I remember a neighbor a long time ago back in China, and she's got a little spot on her right foot, I think, behind the heel, and then only about half centimeter or something, quarter-inch big. And then when the doctor said that's a cancer, and she died within 1 week. All right. I don't know, it was scared to death or something, but happened to her 1 week, she's gone. So the skin cancer. So, but UV ray is not very strong, but strong enough to hurt the cell on your skin. Now people say this, right? You heard that slang says, the beauty is only skin deep, right? That means skin very thin, right? Skin very thin layer. So if the UV ray is able to penetrate the skin, means passing through the skin and passing through all the cell on your skin, and all the cell get hurt because under exposure of UV ray, and then the cell got destroyed and they got a mutation and then form cancer or tumor, and then you got a problem, right? So that's UV, all right? Now after UV, we have a very small narrow band, right? Small region, right? Small region, we call visible. Visible ray. The visible is what? Visible is the color, right? Basically the color. Now the colors of all kinds, if visible, the color. And the UV, right? UV. And the next to is visible. The visible ray, you can say it is not harmful, right? In short term. But think about it. If you drive on highway, one lane, right? Two-way street in the night. And it just happened all the time. I think somebody, you're driving, approaching you, forgot to turn off the high beam of the headlight of his or her vehicle, right? What do you feel? You feel you're blinded by the oncoming vehicle with high beam. That hurts. You press home or you flip your high beam light headlight to warning or tell this person, the driver, hey, cut off the high beam. Sometimes you'll get response, sometimes you won't, right? But if you have a lucky case and someone turn off, soon after the oncoming vehicle turn off the high beam headlight, what happens if you close your eye briefly? You see two spots, sometimes green color of the headlight image, still the residue of the image still remain on your retina. Is that going to hurt? Of course. For a short period of time, which is one burst, it's not. But if in the long time, that's why you do not supposed to look directly into the sun during any sunny day, right? Not any seconds. It's going to hurt you, hurt your eye, right? Eye is another case says eye is a very tender organ of the human body. Now after UV, we have this NIR. It's called near infrared. What does infrared stand for? It basically is heat. Near infrared. That band followed by a band called infrared. Infrared. Infrared radiation or infrared radiation. What is the layman term for infrared radiation? Basically, it's the heat. Heat. The fire, the heat, right? The heat, the fire, right? And then, is that also harmful? Well, you can look upon the fire burning. It's not going to hurt your eye. If it's not going to hurt your eye, it's not going to hurt your body, unless you walk into the fire, right? But if you get into the fire, the temperature is too hot, right? Temperature is too hot, and you'll get burned, right? So that is the reason you don't get close to the heat, but you can watch the heat. It's not going to hurt, but if you get approach or get into the fire, you got to burn. So it's heat. Now, what's the application for the infrared in our routine life? It's a remote control. Remote control unit is based on the concept of infrared. In the old time, if you have ever seen, probably never seen that before, you check the remote control. Nowadays, the remote control doesn't even have that kind of device at the tip of the remote control. Say this is a remote control, the old time remote control. On the front of this remote control, you have a small window. And the window is made of plastic window. The plastic color is red. And nowadays, I don't see this. But that also tells us, has something to do with infrared. Infrared is kind of red color, right? Infrared. So infrared is the heat and or fire. Right? Now, so we are in the middle, almost past the safe zone, right? So here's a safe zone for visible light, different colors, right? 7 colors, right? Blue, red, yellow, orange, green, purple, right? And if you go in this way, it's more harmful, right? Right? And again, this way is safer, a little safer, but not really, right? So let's talk about the next one after infrared. We already said infrared, this radiation can also hurt if you step into the burning zone with the infrared, right? Generated. And then the next one is microwave. microwave band. Now the microwave band, we know that. The microwave, well, we're getting close to the right end of the spectrum. Of course, the frequency getting lower and lower and lower, the wavelengths getting longer and longer, right? Now, the energy getting lower and lower as well, and the penetration power is getting weaker and weaker, right? Weaker. So, or lower. So the microwave, what about microwave, right? Microwave, right? It can hurt too. I don't know if you ever heard some crook, some evil person. I remember that was in Pearl, long time ago, maybe 10 years ago. The guy, he placed his kitten into the microwave oven and turned on the microwave and killed the kitten. That is torture. That is evil. All right. So microwave. What microwave can do? Microwave oven, right? The oven, the applications oven, can heat up food. But do you realize you do not use a microwave oven to heat up your bread without wrapping the bread with a saran wrapper to keep the moisture inside? Even though you put the bread inside a saran wrapper, it will still do the same thing to the bread if you put time of a microwave operation too long, over 30 seconds or 1 minute or two. The bread getting so hard, so dry, and it's so tough to chew on it, it may break your teeth. Why? Because the microwave is operating upon the vibration of water molecule. So if you do not keep the water molecule next to the starch, which is made of bread, right? Starch or gluten. And then the water vapor evaporizes when the microwave starts vibrating the water molecule getting excited and then heat up, and then they beyond its evaporation point, which is the boiling point, or become vaporized, right? Vaporization. And then all of the bread got starch and gluten only, and then you keep on heating and then getting dried out. So your bread getting dried is so tough. So you have to keep in the plastic wrapper or plastic container and heat more than 10 minutes, 10 seconds is probably good enough for sometimes you try to come, because the different size of your bread, you may put 30 seconds or only 15 seconds to start with, right? You always can reheat. So the function for microwave to work as microwave oven is to provide just enough, because microwave is lower frequency, lower energy, just enough energy to be able to shake up the molecule of water in the moisture. And then you have something shake up and start to vibrating between the water molecule, they rubbing each other, right, because of vibrating. And then generates a lot of friction. The friction will generate a lot of heat. Have you ever rubbed your hand in the wintertime? Do you feel the palms getting warmer? So that's the same situation in the microwave oven when the water molecule getting vibrated, and then to rub each other against each other to generate a little heat. So that amount of heat is used to heating things up. That's one application. If you don't know, now you know. And the second one is what? Cell phone. The cell phone, I believe, is operating on the band of microwave radiation. So the cell phone is operating on the microwave radiation band. Now, something happened in the past, right? There was a very famous lawyer. His name is Johnny Cochran, right? He's O.J. Simpson's lawyer. And he died 10-some years ago already, and people said he died because he's a lawyer. He received so many phone calls every day, right? Because of the business, right? People calling him for advice, the legal advices, and he's on the phone all the time. And back to 10-15 years ago, the cell phone is not this small; it's big, right? And he's the only big cell phone in Los Angeles, and they answer all the phone calls. And he plays the phone, the receiver, right, of the phone, next to his ear to listen, right, and talk. And the microwave concentrated and then somehow get into his head. So he got a brain tumor and he died of it. But I have a doubt about this theory, right? Yes, he passed away. But is that because his tumor is caused by the microwave from the cell phone? I don't know. But I would doubt it. Because why? Scientifically, we just learned. Look, the microwave band, where it is. Is that on the left side of the spectrum with very high frequency, high energy, high penetration power? No, it is not. It's almost the end of the spectrum. It has the lowest frequency, right? Longest wavelengths means very difficult to penetrate into some gaps. It's narrower, right? And it has a lower energy and close to weeks the penetration power. So I have a doubt if he died of brain tumor because he used cell phone too much. Now think about it. You may find out later on, right? I don't have time to deal with this anymore, but it's good enough we talk about this. This is a real life situation. He did. He died of a brain tumor. And we can easily connect to his usage of a cell phone because he's a lawyer, right? But is that related at all? We don't know. We try to find out, right? So here, microwave. So two applications we normally know right now. So the last one is a radio band, and the TV, right? TV, radio. The broadcasting, the radio frequency, all right, is the lowest frequency in the entire spectrum of electromagnetic radiation, which is auroral ray, which includes almost all the different type of energies in different kind of band and the wavelengths in the spectrum, right? So what is the radio frequency? The lowest one, and the lowest frequency, lowest energy, all right? And we all know that because we sometimes listen to the radio, right? So in the radio frequency, we have these, right? We have the radio frequency, right? The radio, so AM band, right? It's called amplitude, amplified. I think it's amplified module, and then the frequency FM, right? And then we have also SW. You familiar with FM, AM, but you're probably not familiar with SW. SW is short wave. So inside the band, the wavelengths is the shortest one inside radio spectrum, right? Other one will be different, the short wave. And also now we have TV, right? TV broadcasting. Now, always, if this in-class lecture, I would always at this moment I would do a survey. I would ask you, all right? So, hey, everybody, listen. If anybody in this classroom, all right, only listen to FM, never listen to AM band. Then in the past we have so many people who say, yeah, I only listen to FM. And very few students will say, I listen both. And then even fewer say, I listen only AM. That's very rare. That's why I would say that to the class, okay, if you only listen to FM, now I will give you an F in the class. Unless you listen to AM, you get A. But now, because you only listen to FM, so you will get F in my class. You like it? Of course not. All right, so that's a small joke. Now we have explained the entire spectrum of the electromagnetic radiation, and so we are able to understand this for the standpoint of the concept, the frequency, the wavelengths, in relation to the energy of individual type of radiation we talk about in the entire spectrum. Alright, so that's the energy. Then those the radiation type. So what is the type the classification of the type of energy, right? We haven't talked about this. So let's talk about, these are all the spectrons, and then they all have everything to do with the solar array, and then, but we also are able to classify different type of energy. So this is one type, this is solar array, just one type of them. Beyond that, we have other types. Alright, so let's say classification of, right, types of energy. Right, types of energy. Alright, now I simply put all these type of energy into 8 categories. 8 categories. Now let's start from potential energy. Now in the mathematic expression for potential energy is mgh. Alright, mgh. Now the m stands for mass, g is the gravity, h is the height or the position of the object we talk about, right? That's height, stands for h, right? Alright, so what is the definition of a potential energy? Potential energy is a position-based energy. Position-based energy, alright? Now, that's the first type. Now, example, chemical bonds in the molecules or formula, they possess potential energy because the position, the angle, the length of the bond, and the shape of the molecule, and representing certain amount of potential energy, because just like a spring-loaded device, you push towards each other and have a resistance to push your hands back. This kind of energy is potential energy because it's the position. Here is a position energy, this, and there's going to be a stronger power make the spring in the contract, and then you have the higher resistance and bounce your hands back. So that is the energy we call potential energy. The second type is the kinetic energy. Kinetic energy, the mathematical expression is 1/2 the mass multiply the velocity being squared. So what is the statement for the definition? The definition for kinetic energy would be what? Velocity, right? Motion based, right? Right, motion was a velocity. Velocity is a part of a motion, right? Motion based energy, right? And motion based energy. All right, so what is the example? And the moving car, right? The moving vehicle will possess the kinetic energy, or the molecule under heat and expand the hot balloon, the air molecule, hot balloon is expanded and then puffed balloon, and the air balloon goes up, right? Hot air goes up because it puffed up, because it got kinetic energy into the air molecule, they bounce into each other, and then they require more space, they bounce, expand, and then the air balloon goes up. That is the motion of molecules, then that involves the kinetic energy. Now time is up, alright, got 10 seconds. Now we stop here, we continue part 10 to finish the law of conservation of energy. Then we get into thermochemistry, then we finish it.